everyone, and welcome to this video going over your Unit 2 exam study guide. For the first couple of problems, we need to determine if each relation is a function and state the domain and range of each relation. Remember, domain is all of your inputs, so all of your x values, and your range is all of your outputs, all of your y values. So for number 1, in my domain, I have -2, -1. Even though -1 repeats, I only have to write it one time. Then I have 2 and 4. Those are all of my x values, all of my inputs. And for my range, I have -4, -2, 2, -5, and -3. Now I have to determine if this relation is a function. Remember, in order to be a function, every input can only have one output. So we should never see any input repeat. But in number 1, I see the input -1 twice, which means this is not a function because -1 has 2 outputs. Let's try number 2. Number 2 is really easy because they tell us what the domain and range is. My domain is everything in the first bubble, so -5, 0, 4, and 7. And my range is everything in the second bubble. -5, -3, 0, 1, and 2. And what I'm looking for is every input should only have one arrow. But if you notice, 0 has 2 arrows coming out of it, which means this is not a function because 0 has 2 outputs. And I'll leave you to try number 3 and number 4 on your own. Now let's talk about function notation. If the value is inside the parentheses, that means it's an input. And we need to input it in for x in our equation. So I have -2. Instead of x, I'm going to say 4 minus 1 plus 2. 4 minus 1 is 3. And remember, those vertical lines mean absolute value. Absolute value needs to make sure that every number inside is positive. Since the 3 is already positive, it is just going to stay positive. -2 times 3 is -6, and -6 plus 2 is -4. Let's try number 6. In number 6, once again, the -2 is inside the parentheses, which means it's an input, and I need to input it into my function every time I see an x. So I see an x here and here. Make sure you have your parentheses, -2 squared plus 4 times -2 plus 2. -2 times -2 is a positive 4. 4 times -2 is -8. Plus 2. 4 minus 8 is -4. Plus 2 gives me -2. Let's move on to try number 9. In number 9, notice how the -2 is outside the parentheses, which means it's an output. That means it's my answer. So I'm going to write out my function, -2 times x minus 5 plus 2, and set it equal to my output. This is equal to -2. In order to solve this, I need to get the absolute value all by itself. I'm going to start by subtracting 2 to both sides. -2 minus 2 is -4. And since this -2 is right next to the absolute value, that means it's being multiplied. So I need to divide to get rid of it. -4 divided by -2 is +2. And remember, when we solve absolute value equations, we need to solve them twice because my answer could be +2 or it could be -2. In order to solve, I have to add 5 to both sides. And I get that x is equal to 7 as one of my inputs. And if I add 5 to the other side, Negative 2 plus 5 is 3. And let's try number 10. Once again, that 3 is outside of my parentheses, which means it's an output. So I'm going to write out my function, negative 4x plus 3, and set it equal to my output, equal to my answer. And now I'm going to solve. I need to subtract 3 to get rid of 3, and I get negative 4x is equal to 0, because 3 minus 3 is 0. And then in order to get rid of the negative 4, I need to divide by negative 4 to both sides. And 0 divided by negative 4 is 0. So please make sure you know the difference between an input and an output. If the value is inside the parentheses, you are plugging it in for x. And if the value is outside of the parentheses, that is your answer. Now let's practice finding the slope of a line. In order to find the slope of a line, you need to pick 2 points where the line crosses the graph at a perfect corner. So notice how I already picked points for you that cross at a perfect corner. And we are going to count the rise and the run. So it looks like I rise 1, 2, 3, 4, 5, 6, 7, 8 boxes. And I run 2 boxes. Rise over run means I have 8 over 2. And we're going to simplify if possible. 2 actually does divide 8. 8 divided by 2 is 4. And so my slope is 4. In number 12, once again, they already picked 2 points for me. I'm going to count my rise and my run. It looks like I rise 1, 2, 3, 4, 5, 6, 7, 8. But notice how my line is going down from left to right. So I'm going to say this is a negative 8 because I'm going down. And my run is 1, 2, 3. So rise over run, I have negative 8 over 3. And there is no way for me to simplify this. So my slope is negative 8 over 3. We can also find the slope between 2 points using this slope formula. Slope is equal to y2 minus y1 all over x2 minus x1. So I'm going to label my points x1, y1, and x2, y2. Make sure every single point has an x and a y. And then I will plug in these values to my slope formula. y2 is 7, minus y1 is 0. All over x2 is negative 2, minus x1 is 1. And then I solve. 7 minus 0 is 7. And negative 2 minus 1 is negative 3. And so this tells me my slope is 7 over negative 3. Let's try 14. Once again, I label x1, y1, x2, y2. And I plug in my values. y2 is 11, minus y1 is 17. x2 is 0, minus x1 is 16. 11 minus 17 is negative 6, and 0 minus 16 is negative 16. And I can simplify this. Both the top and the bottom are negative, which means those negatives cancel out. And both 6 and 16 can be divided by 2. 6 divided by 2 is 3, and 16 divided by 2 is 8. So my final slope is 3 over 8. In our next set of questions, they are giving us slope-intercept form, and they want you to make sure you can identify the slope. The slope is always in front of your x. So in 15, I have y equals 2 over 5x plus 5. The slope is 2 over 5. And the 5 is your y-intercept, in case they ask that as well. In 16, I have y equals 7 over 3x plus 2. The 7 over 3 is my slope, because that is what is in front of the x. And that plus 2 is my y-intercept. Now they want you to write the slope-intercept form of the equation of the line. Remember, slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. So in 17, it looks like my y-intercept is -3. So I'm going to make a note that my b value is -3. And now I need to figure out my slope by finding 2 points that cross at perfect corners. So I'm going to use my y-intercept because that crossed at a perfect corner. And it looks like another good point is right here at 1, 1. And now I'm going to count my rise over my run. I rise 1, 2, 3, 4, and run 1. So rise over run, my slope is 4 over 1, which we can simplify to just 4, because 4 divided by 1 is 4. And now putting these pieces into my equation, I will have y equals 4x minus 3. Let's try 18. In 18, my y-intercept is 4, so my b value is +4. And now I need to find another point that crosses at a perfect corner to find my slope. I'm going to pick this point right here, 4, 1. And now I'm going to count the rise and the run. Please be mindful that your line is going down. So I go down 1, 2, 3 boxes. So my rise is -3. And I run 1, 2, 3, 4 boxes. So rise over run is -3 over 4. And plugging these values into my equation, I will have y equals -3 over 4x plus 4. We are going to do the same thing, but instead of looking at a graph, they are going to tell us what the slope and the y-intercept are. Remember, your slope is your m value, and your y-intercept is your b value. And all we're doing is plugging them into y equals mx plus b. So here I have y equals, my slope is -2 over 5, x, and my y-intercept is -1. In 20, I have my slope and my y-intercept, my m and my b. I will have y equals 7 over 5x plus 3. In our next section, we need to rewrite each equation in slope-intercept form, which means we need to solve each of these equations for y. So I'm going to circle y to show me what I'm solving for. And the first thing I will do is subtract x to both sides. And I will be left with -8y is equal to -x plus 24. I like to put the x in front because we're used to mx plus b. Notice how the x goes first. And then in order to get y by itself, I'm going to divide everything by -8. And I will have y equals, notice how I have -x divided by -8. Those negatives will cancel out. And I have an imaginary 1 in front of my x. So this is 1 over 8x. And 24 divided by -8 is -3. And that is my slope-intercept form. Let's try 22. In 22, I'm going to start by subtracting 3x to both sides. And I'll be left with -2y is equal to -3x minus 8. And then lastly, I divide everything by -2. And I'll be left with y equals, since both the 3 and the 2 are negative, those cancel out, leaving me with a +3 over 2x. And -8 divided by -2 is a +4. In 23 and 24, in order to rewrite these in slope-intercept form, I have to start by double rainbowing, or distributing. So I'm going to do -4 times x, which is -4x, and -4 times 2, which is -8. And I still need to get y by itself, and I do that by subtracting 1. And I subtract the 1 from the -8 because they are like terms. -8 minus 1 is -9. And in 24, once again, I need to double rainbow first. 2 times x is 2x, and 2 times 3 is 6. And in order to get y by itself, I subtract 2 to either side, and I'm left with y equals 2x plus 4. So please make sure that you know how to rewrite either a standard form equation or a point-slope form equation into slope-intercept form, because slope-intercept form is our favorite form, and it helps us graph our lines. In 25 and 26, it says write the point-slope form of the equation of the line through the given point with the given slope. Point-slope form is y minus y1 is equal to our slope m times x minus x1. So our slope is our m value, and they give us a point which is going to be our x1 and our y1. And all I have to do is plug in these values to my point-slope form. So I have y minus y1, which is negative 2, is equal to m, our slope, which is 0, times x minus x1, which is 4. And I'm going to simplify this. Because I have two negatives right next to each other, that's going to turn into a big plus. And then notice how I have this x minus 4 times 0. Anything times 0 is just 0. So this is going to simplify to y plus 2 equals 0. And that's your final equation. In 26, I have once again my x1 and my y1, and my slope is my m value. And I have y minus y1, which is negative 5, equal to my slope, which is 3 over 2, times x minus x1, which is negative 4. And once again, if you ever have two negatives right next to each other, that turns to a big plus. In the next section, it says write the equation of the line in any form of the line described. Remember, parallel lines have the same slope, and perpendicular lines have opposite reciprocal slopes. So in 27, it says that we need a line that goes through 1, negative 1, and is parallel to y equals negative 4x plus 2. The slope of the line that they gave me is negative 4. And since they want a line that's parallel to this one, I know that parallel lines have the same slope. So my new line will also have a slope of negative 4. Since I have the slope and a point on my line, I'm going to use point-slope form, because that's the easiest form to use when you have a point and a slope. Remember, point-slope form is y minus y1 is equal to the slope times x minus x1. So this will be my x1 and my y1. So I will have y minus negative 1 is equal to negative 4 times x minus x1, which is 1. And if you have two negatives right next to each other, that turns to a big plus. Let's skip to 29. In 29, it says that I want a line that goes through 1, negative 2, and is perpendicular to y equals 1 over 4x plus 1. The slope of this line is 1 over 4. If I want a slope that's perpendicular to this one, I need to find the opposite reciprocal, which means I need to flip this and change the sign. Since I had a positive 1 over 4, my new slope is going to be a negative 4 over 1, which we can simplify to just negative 4, because negative 4 divided by 1 is negative 4. And once again, since I have my slope and a point on my line, I will use point-slope form. So y minus y1, which is negative 2, is equal to my slope, which is negative 4, times x minus 1. Since I had two negatives right next to each other, that will turn to a big plus. Please remember that parallel lines have the same slope and perpendicular lines have opposite reciprocal slopes. Let's move on to some graphing. With graphing, if they give you slope-intercept form, your constant, the number all by itself, is your y-intercept. That's your starting point. So my starting point is going to be 3 on the y-axis. And your slope tells you how you move, rise over run. Since I have the slope -2/5, and even though the negative's right out in front, I just like to put it with the number on top so I don't lose it. And this tells me that I go down 2 and to the right 5. Down 2 to the right 5. If you run out of room, you can go backwards by flipping your directions. So instead of going down and to the right, I can also go up and to the left. So I can also go up 2 and to the left 5. And notice how my line is going down. That's perfect because my slope was negative. So if you have a negative slope, your line should be going down. Let's try 32. In 32, my y-intercept is 3. So that's my starting point. And my slope is a +3/2. That tells me that I go up 3 and to the right 2. So up 1, 2, 3, and to the right 2. If you run out of room, you can go backwards. And in order to go backwards, you flip both directions. So instead of going up and to the right, we can go down and to the left. So down 3 and to the left 2. Down 3 and to the left 2. Down 3 and to the left 2. The more points you add, the straighter your line is going to be. Now that's how we graph with slope-intercept form. Let's say they give you the equation in standard form, like in 33 and 34. We need to rewrite these like we did earlier in the study guide. In order to do that, I need to get y by itself. So the first thing I'm going to do is subtract 3x to both sides. And I will have 4y is equal to -3x plus 12. And then I'm going to divide everything by 4. And I will be left with y equals -3/4x. 12 divided by 4 is 3, so plus 3. So this tells me that my y-intercept is +3, and my slope is -3/4. That tells me that I go down 3 and to the right 4. So down 3 to the right 4. Or up 3 and to the left 4. And my line is going down, which is perfect because my slope is negative. Let's try 34. Once again, I need to rewrite this into slope-intercept form. So I'm going to subtract 3x to both sides. I will be left with -4y is equal to -3x minus 16. And then I will divide everything by -4. Because both the 3 and the 4 are negative, they can cancel out, leaving me with +3/4x. And -16 divided by -4 is a +4. So my y-intercept is +4. And my slope tells me I'm supposed to go up 3 and to the right 4. But I don't have enough room to go up 3, so I'm going to go backwards by going down 3 and to the left 4. In 35, I have y equals -2. Whenever you have y equals just a number, you are going to have a horizontal line because your line needs to go through the y-axis. So I find -2 on the y-axis, and I draw a perfectly horizontal line through -2. Every single point along that line has a y value of -2. And in 36, we have x equals 2. If you ever have x equals just a number, we are going to have a perfectly vertical line because we need our line to go through the x-axis. So I find 2 on the x-axis, and I'm going to draw my line perfectly vertical through 2, because notice how it goes through the x-axis. And the last problem we are going to do together is number 37, practicing our key features of graphs. Domain is left to right. So looking at number 37, notice how I have an arrow going to the left. That means I'm going towards negative infinity, and I use a parenthesis for infinity. And I'm also going to infinity on the right because I have another arrow. So my domain is negative infinity to infinity. For my range is low to high. It looks like I'm going low forever, so I'm going to have negative infinity. But I only go as high as this value right here, which is the y value 1. And that's a closed circle, so I'm going to have a bracket on 1. My y-intercept is where I cross the y-axis, and it looks like I crossed the y-axis right here at negative 2. So that is the point 0, negative 2. And now we have to find our lowest and highest y value for our absolute minimum and maximum. Since I'm going low forever, I'm never going to reach a lowest point, so I have no absolute minimum. But my absolute maximum is my highest y value, which is 1. Make sure your absolute minimum and maximum match your range. Notice how my low end was negative infinity, which makes sense on why I did not have an absolute minimum. And my highest y value was 1, which matches the 1 on the right side of my range. I hope this video helped you get a very good head start on your Unit 2 exam study guide. Please let me know if you have any questions, and happy studying!